Download this code from codegive.com, link in the description below. The importance of error handling in C, a detailed tutorial with examples. Error handling is a crucial aspect of writing robust and reliable C programs. Ignoring potential errors can lead to unexpected behavior, crashes, security vulnerabilities, and ultimately, a poor user experience. This tutorial will delve into the importance of error handling in C, exploring various techniques and providing comprehensive code examples. Why error handling matters. 1. Preventing crashes ** unhandled errors, like dereferencing a null pointer or dividing by 0, often result in program crashes. Error handling allows you to gracefully respond to such situations, preventing the program from terminating abruptly. 2. Maintaining program stability * by anticipating potential errors, you can implement mechanisms to recover from them, keeping the program running smoothly. This might involve retrying an operation, providing default values, or informing the user about the issue. 3. Ensuring data integrity * errors can corrupt data. For example, a failed file write operation might leave a file in an inconsistent state. Proper error handling can help detect and prevent data corruption. 4. Improving user experience * instead of displaying cryptic error messages or crashing the program, error handling allows you to provide informative messages to the user, guiding them towards resolving the problem or preventing it in the future. 5. Debugging and maintenance * well-handled errors make it easier to identify and fix problems during development and maintenance. By logging errors and providing debugging information, you can quickly pinpoint the source of the issue. 6. Security * ignoring errors can create security vulnerabilities. For example, an improperly validated input value could lead to a buffer overflow. Error handling can help detect and prevent such vulnerabilities. Common sources of errors in C. Invalid input * user input that doesn't conform to the expected format or range can cause errors. Memory allocation failures * malloc, and calloc, can fail to allocate memory, returning null. File I/O errors * opening, reading from, or writing to files can fail due to various reasons, file not found, permission denied, disk full, etc. System calls * many system calls, example socket, read, write, can fail and return error codes. Arithmetic errors * division by 0, integer overflow, and other arithmetic errors can occur. External dependencies * errors can arise from external libraries or resources, network connections, databases. Basic error handling techniques in C. 1. Checking return values * most C functions return a value indicating success or failure. The most fundamental error handling technique is to check these return values and take appropriate action if an error occurred. Example, file I/O. Explanation **. Foopan, attempts to open the file myfile.txt in read mode. If foopan, fails, example the file doesn't exist, it returns null. The if, fp == null, condition checks for this error. Per error opening file, prints an error message to str including a system-specific description of the error, obtained using errno. Per is very useful when dealing with standard library functions. Return 1 indicates that the program exited with an error code. A return value of 0 typically signifies success. 2. Using errno *. The errno variable, defined in errno.h, is a global variable that stores the error code of the most recent failed system call or standard library function. After a function fails, you can check the value of errno to determine the specific error. It's crucial to check error no immediately after the potential error occurs, as subsequent function calls can overwrite its value. Asterisk example, string conversion. Explanation asterisk. Asterisk strtl attempts to convert the string str to a long integer. Asterisk error no equals 0, important asterisk resetting error no before the call is essential. This ensures that you're checking the error no value specifically related to the strtl call and not a previous error. Asterisk if error no equals 0 checks if an error occurred during the conversion. Asterisk per error converting string to long prints a generic error message. Asterisk if error no equals range checks for the specific error range error, which indicates that the converted value is outside the representable range of long. Asterisk we also check the converted value to see if it can fit into an int. 3 using per and fprintf. Asterisk per, as shown in the file IO example, is a standard library function that prints an error message to str along with a system-specific error description. Fprintf can be used to print customized error messages to str or other streams. Asterisk example, custom error message. Explanation asterisk. Asterisk fprintf, str, error, operation failed with code %d\n, result, prints a custom error message to str, including the error code. Using str ensures that error messages are clearly distinguished from normal output. For assertions, assertions are useful for detecting programming errors during development. They check for conditions that should always be true. If an assertion fails, the program terminates with an error message. Assertions are typically disabled in production code. Asterisk example asterisk. Explanation asterisk. Asterisk assert, b, equals 0, checks if b is not 0. If b is 0, the assertion fails, and the program terminates with an error message indicating the line number and the assertion that failed. Asterisk when compiling with the debug flag, example gcc debug myprogram.c, assertions are disabled. Advanced error handling techniques. 1. Exception handling. Simulated C doesn't have built-in exception handling like C++ or Java. However, you can simulate it using setjump and longjump. This is generally discouraged for simple cases due to complexity and potential performance overhead but is necessary for some complex scenarios. Asterisk example asterisk. Explanation asterisk. Asterisk jmp_buff_env defines a jump buffer to store the program state. Asterisk setjump env saves the current program state in the env buffer and returns 0. Asterisk longjump env error_code restores the program state saved in env and causes setjump to return error_code. This effectively jumps back to the setjump call. Asterisk error_handler, a function to handle errors. It prints an error message and then jumps back to the setjump call using longjump. Asterisk the if setjump env equals 0 block represents the normal execution path. If an error occurs, b equals 0 in divide, error_handler is called, which then calls longjump, causing the program to jump back to the setjump call. This time, setjump returns the error_code, 1 in this example. Asterisk the else block handles the error. It prints an error message and continues with the program's execution. Limitations of setjump and longjump, asterisk. Asterisk stack unwinding asterisk longjump doesn't perform stack unwinding like proper exception handling in other languages. This means destructors for objects on the stack won't be called, which can lead to resource leaks in C++ if used improperly. Asterisk readability. Asterisk the code can be more difficult to read and understand compared to structured exception handling. Asterisk performance. Asterisk there can be some performance overhead associated with saving and restoring the program state. 2. Returning error codes as structures. Asterisk when a function needs to return both a result and an error status, you can define a structure to hold both values. Asterisk example. Asterisk explanation. Asterisk operation result structure defines a structure to hold the result of an operation, a boolean indicating success or failure, and an optional error message. Asterisk safe_divide function. This function performs a safe division, checking for division by 0. If division by 0 is detected, it sets success to false and provides an error message. Otherwise, it sets success to true and returns the result. Asterisk the main function checks the success flag of the operation result and prints either the result or the error message accordingly. 3. Using callbacks for error handling. Asterisk callbacks allow you to register a function that will be called when an error occurs. This allows for centralized error handling logic. Asterisk example. Asterisk explanation. Asterisk error handler type def defines a type for a function pointer that takes an error message as input. Asterisk global_error_handler, a global variable to store the currently registered error handler. Asterisk set_error_handler, a function to register a new error handler. Asterisk divide function. If b is 0, it calls the registered error handler, passing the division by 0 message. Asterisk main function. It sets a custom error handler and then calls divide. When division by 0 occurs, the registered error handler will be called. Best practices for error handling in C. Asterisk check return values consistently. Asterisk make it a habit to check the return values of functions that can fail. Don't assume that functions always succeed. Asterisk handle errors close to the source. Asterisk handle errors as close as possible to where they occur. This makes it easier to understand the context of the error and to take appropriate action. Asterisk use per for system errors. Asterisk per is the preferred way to print error messages related to system calls or standard library functions that set error no. Asterisk provide informative error messages. Asterisk error messages should be clear, concise, and helpful to the user or the developer. Include relevant information such as the file name, line number, and the specific error that occurred. Asterisk log errors. Asterisk consider logging errors to a file or other storage mechanism. This can be invaluable for debugging and monitoring your application. Asterisk centralize error handling. Asterisk for more complex applications, consider implementing a centralized error handling mechanism, example using callbacks, to ensure consistency and reduce code duplication. Asterisk document error conditions. Asterisk clearly document the potential error conditions for each function in your API. Asterisk clean up resources. Asterisk when an error occurs, make sure to release any resources that have been allocated, example close files, free memory. This prevents resource leaks. Asterisk avoid ignoring errors silently. Asterisk never simply ignore errors without taking any action. At the very least, log the error or print a warning message. Ignoring errors can mask underlying problems that can lead to more serious issues later on. Asterisk assertions for development. Asterisk use assertions to catch programming errors during development, but disable them in production code, using debug. Asterisk choose the right technique. Asterisk select the appropriate error handling technique based on the complexity of the situation and the requirements of your application. For simple functions, checking return values and using per might be sufficient. For more complex situations, you might need to use structures, callbacks, or, very rarely, simulated exception handling with setjamp/longjamp. Example, comprehensive error handling in a file copy function. Explanation asterisk function copy underscore file, asterisk encapsulates the file copying logic. Asterisk error handling asterisk each function call that can potentially fail, example fupin, Fred, Fright, Ferrer, is checked for errors. Per is used to provide detailed error information. Asterisk goto error asterisk a goto statement is used to jump to a central error handling block. This allows for consistent cleanup of resources in case of an error. While overuse of goto is generally discouraged, it's often acceptable, and even recommended, for error handling scenarios like this. Asterisk resource cleanup asterisk in the error block, any open files are closed to prevent resource leaks. Asterisk error codes asterisk the copy underscore file, function returns an error code, 0 for success, 1 for failure, to indicate whether the operation was successful. Asterisk binary mode asterisk the files are opened in binary mode, RB, WB, to handle all types of files correctly, avoiding potential new line translation issues on some systems. Asterisk Ferrer asterisk after the Fred loop, Ferrer, src underscore fp, checks if an error occurred during reading the source file, which could be caused by a corrupted or incomplete file. Conclusion: error handling is an essential part of writing robust and reliable C programs. By checking return values, using errno and per, and employing more advanced techniques when necessary, you can significantly improve the stability, maintainability, and security of your code. Remember to prioritize clear and informative error messages, consistent error handling, and proper resource cleanup. By following these principles, you can create C applications that are more resilient to errors and provide a better user experience.